Hello mga ka-Johnny! Welcome back to my YouTube channel. Again, this is Sir Robin Sanipulan, your partner in learning mathematics. But before you begin in this video, do not forget to click the subscribe button and give me a thumbs up if my video helps you. But before you watch in this video, I do hope that you are taking down notes and you already watched my previous video entitled Continuity of a Function in an Interval Part 1. Because in this video, this is the continuation of that video. If you're not yet watched that video, do not proceed in this video. Okay? So without further ado, let's try some practices regarding continuity of the function in an interval. Because we believe that constant practice is a skill in mastering the topic. Okay, so now this is the problem that we are going to try if it works. The question is, f of x is equal to the square root of a minus x squared. So meaning that is our function. Let's try to test. Let's try to show if this function works in this interval. And obviously, our interval is a closed interval. What does it mean when I say it works in our function? Meaning, all numbers in between this interval works, or once you substitute in our function is still defined. We still have value to know it, right? That's what I'm trying to say. If all the values of this works, therefore, that is continuous. If there are at least a value in this interval that makes your function undefined, meaning that is not continuous at that point. So how are we going to know if this function is continuous in this interval or not? Since we are dealing a closed interval, in short, we are going to use condition number 2. And that condition number 2 has three conditions in order to prove if condition number 2 works. We have A, B, and C. So let's try to use this following condition if it works in this one. So let's try condition letter A. For condition letter A, let's try to check in an open interval if this function works. In short, let's try to change this closed interval into an open interval. It will become negative square root of 8 and square root of 8. Let's try to test if this function works in this interval between this number. This is how are we going to check it easily. First, you consider this one as A and B. Again, A as the least value and B is the greatest value. You are going to substitute the least value in your function and the greatest value in your function. If the value exists, there. Meaning, it works in the interval. Again, take note that function has radical sign. We are trying to avoid a negative result in that radical sign. In short, a square root of any negative number is an imaginary number, meaning that is no longer a real number. In this section, you are trying to deal only with real number. So without further ado, let's try to test this one. So f of a, let's try to solve it here. F of a, what is your a? That is square root of 8 or negative square root of 8. What is your function? That is 8 minus x squared. And let's try to substitute. What is your a again? That is negative square root of 8. And substitute that one in the x. 8 minus negative square root of 8 squared. After that one, simplify that one. We believe that we can able to cancel square root radical sign, right? As you can observe, we have negative here and we have 2 here. So negative times negative, that is positive. What is the remaining value now? That is 8 minus positive 8. Again, How did we get a positive 8 here? Because we have negative here. Negative squared, that is positive. And we can able to cancel radical sign. As you can observe, 8 minus 8, and we believe that is 0. And what is square root of 0? That is, very good, that is 0. Question, is negative square root of 8 defined in this function? Yes, it's defined at 0, meaning the least value is defined. Let's try the greatest value, that is f of b. What is your b? That is square root of 8. Again, the greatest value in the interval. Let's try to substitute that one in our function. And our function is 8 minus x squared. And what is b again? That is square root of 8. Let's try to substitute that one. 8 minus square root of 8 raised to the power of 2. And we believe we can able to cancel that one out. So that is now 8 minus 8. And we believe 8 minus 8 is 0. And square root of 0 is 0. Question, is the greatest value in the interval defined in our function? Yes, it's defined as 0. In layman's term, we have a value 0 when we substitute square root of 8. Question now, is our function continuous in the open interval? Yes, simply because it works in the least and greatest value. If it works at the least and greatest value, meaning it also works on the number in between. If it works at every number in between the open interval, meaning we can conclude that that is continuous in the open interval. If that is continuous in the open interval, condition letter A works. So we are done with condition letter A. That's how condition letter A works. Done proving condition A, and luckily it works. Now, let's try to prove or to test condition B. For condition B, if you still remember, condition B, that is testing the least value of the interval, which is this one is our A, and this one is my B, and I have to test for condition B, the least value of the interval, or A. We have to test if f of A exists, and the limitation of f of x as x approaches to A positive also exists. And these two are equal. If it exists, and the limitation also exists, and they are equal, meaning that we are done with condition B, and it works. Let's try if in this problem condition B works. Take note that I am here to prove f of A, and my A here is the least value of the interval, and that is negative square root of 8. I have to test if it works. Again, A here is negative square root of 8. And I have to test it here. F of A, or my A here is negative square root of 8. From the function, square root of 8 minus negative square root of 8. And I believe we're already done doing this one in condition A. And the result here is 0. Question, is f of A exist? Yes, it exists at 0. Meaning, we have a right to proceed to the limitation if it works. Here, it works. Let's try it here. So here, we are trying to prove if the limit exists. If the limit exists, then that's all. Let's try. So this is now the limitation of what is my f of x? My f of x here is 8 minus x squared. As x approaches to, what is the value of my a? The value of my a here is negative square root of 8. And I have to consider positive, or to the right of negative square root of 8. I have to test if the limit of this function exists. Same thing. We have to prove, or we have to use two steps in proving the limit if the limit exists. Step 1 is, I have to consider where my x approaches to, disregarding the sign at the top. So in this problem, my x approaches to negative square root of 8. So that is my x, negative square root of 8. So after identifying that one, I have to substitute that one in the numerator of my function. And obviously, this is my numerator, right? So that is now 8 minus negative square root of 8. And we are also done doing that one. What is the result of that again? Same thing here. That is 0. That is step number 1 if the limit exists. Let's try step number 2. For step number 2, you have to try all this value, considering the sign at the top. So that is now negative square root of 8 positive, or to the right of negative square root of 8. I know it's hard for you to identify what is the value to the right of negative square root of 8. 1. For step number 2, we are now here to consider all the values considering the sign at the top. So my x approaches to negative 8 positive, meaning I have to choose at least one number that's located to the right of negative square root of 8. We believe that in every negative number, we can see 0 as part of its value to the right, right? So meaning I can choose here x is equal to 0. Is 0 belongs to the right of negative square root of 8? Yes, that belongs there. Now, after you choose at least a number that is located to the right of your a, you're going to substitute that one to the denominator of your function. In this case, let me clean this one. In this case, the denominator of my function is only 1, right? So meaning, I have to consider 1 here. So that is now f of x is equal to 1. In short, my chosen number 0 should be substituted here. But the question is, I have only a constant function. Is there any change if I'm going to substitute it here? No, because my function is constant. There's no change if I'm going to use 0. In short, the result is still 1. Nothing changed because my denominator is constant. Any values chosen there could not affect the value of my constant function. In short, I am done with step number 1 and step number 2. After doing that one, you have to do it like this. What is my numerator? My numerator is the result of my step 1. And the result of my step 1 is 0. What is the result of my step 2? The result of my step 2 is 1. If you are to divide that 1, 0 divided by 1, that is 0. Now, question. Is the limitation exist? Yes. The limitation exists at 0. The evaluation of function is 0 and that exists. The limitation also, as x approaches to a positive or to the right of a, also exists and that is 0. The last thing that we need to do for step letter B is that to compare the result. The result here is 0 and the result also here is 0. Question, is the result equal? Obviously, the result are equal. Therefore, condition B is checked. Again, check if it exists. Second is, the limitation exists and compare the result. In my case, both exist and the result are the same. In short, condition B is now checked. That's how you do condition letter B. We are done with condition A and B, and luckily, it works. Last one, to prove or to show that this function is continuous in this closed interval, and that is condition letter C. For condition letter C, it is now to test the large or the greatest value of the interval. In condition B, we tested the least value of the interval. This time, the greatest value of the interval. We are going to test if f of b exists, and that should be equal to the limitation of f of x as x approaches to be negative also exists. If both are exist and they are equal, therefore, we are done with condition letter C. Let's try this one, if f of b exists. Take note here that your b is the greatest value of the interval, meaning my b here is square root of 8. Again, this is my a and this is my b. After that one, you have to substitute it to your function. And this is my function. F of square root of 8 is equal to 8 minus square root of 8 squared. And obviously, we can able to cancel that one. So 8 minus 8, that is 0. And square root of 0, that is also 0. Question is f of b exist? Yes. It exists at 0. So now, let's try to check if the limitation of the function exists. It will become the limitation of, what is your f of x? That is square root of 8 minus x squared. As x approaches to, what is your b? My b is square root of 8. It should be at the left of my square root of 8. Same thing that we did in condition letter B. We have to follow 2 steps in identifying the value. This time, let's follow step number 1. Again, step number 1, you have to identify where your x approaches to, and you consider that one as your x. Here, my x approaches to negative square root of 8, disregarding the sign at the top. So this is now x is equal to square root of 8. Again, where your x approaches to, disregarding the sign at the top. So that is x is equal to square root of 8. After that one, you have to substitute this one in your function or in the numerator of my function. Take note that this is my numerator and my denominator is 1, right? That is in my function. So I have to substitute here in the numerator. So that is 8 minus square root of 8 squared. And that is 8 minus 8. You can able to cancel that one out. 8 minus 8, that is 0. And square root of 0 is 0. And we are done with step number 1. This time, let's proceed to step number 2. For step number 2, we have now to consider the entire value, considering the sign at the top. Meaning, that is square root of 8 negative. It means we have to choose at least one value that's located at the left of positive square root of 8. At least choose one value. I know that it's very hard for you to choose at least one value. The best way to choose that one is the easiest way for you. So since we have to choose a square root of 8, that is approximately 2 square root of 2. So you can choose 2. You can choose 2, you can choose 3. Any number, you can choose 0. So in my case, I would like to choose x is equal to 2. Is x is equal to 2 located at the left of square root of 2? Square root of 8? Yes. So I'm pretty sure that x is equal to 2 located at the left of square root of 8. You can choose any number for as long as it's satisfied to the condition. So now, I have to substitute x is equal to 2 to the denominator of my function. Take note that my function here, or the denominator of my function, is 1. Meaning, I have to substitute it there. My function now here is f of x is equal to 1. If I have to substitute 2 here in my function, is there any change in my function 1? No. Because my function is a constant function. Meaning, it doesn't change. There is nothing change happen, or it will not be affected if we put any value there, because that is constant. In short, if we're going to substitute it here, that is plainly constant, so meaning the result is still 1. So that is the result for our step number 2. Now, we are done step number 1 and step number 2. Let's try to find out what is the result. Proceed it here. You have to make it like this. For your numerator, what is the result for your step 1? The result for your step 1 is 0. And the result for your step 2 is 1. If you are to divide it 1, the result is still 0. Now, the question is the limitation exist? Yes, it exists at 0. If f of b exists, and our limitation also exists, that's good. If it exists, now let's compare the result. The result for this one is 0, and the result here is 0. Obviously, the results are equal. F of b exists, limitation exists, and the results are the same. In short, step B, or condition B, works. Condition C rather, works. Now, condition A works, condition B works, and condition C works. In short, we can say that this function works in this interval. Meaning, whatever the value in this interval from negative square root of 8 to positive square root of 8, in between and including this term or this value, the function is still defined. Meaning, the function still works with no holes, no breaks, and no gaps. That's how this problem works.